Okay, so we've set up a couple different animations with walk right and idle right. And as you can see in our player script, when the script first runs, we can travel to the walk right animation using our state machine. You just do travel and the name of the animation you want to reach. And how we get that state machine is by referencing the animation tree in our hierarchy and then getting the playback parameter from that, which gives us our state machine, as long as the tree root is a animation node state machine. So with this setup, that will work all right. So now how do we go from there and actually add some logic so that we can determine when we want to be playing walk right or idle right as our animation? So we've already set up the animation. So we've already set up the animation node state machine to be set up enough for this, but we need some code to determine that. So in our code, we can check if the player is putting in input for walking, and then if it is, the character's walking, moving in a direction, then we can play the right animation in order to accompany that. So let's go up to project settings, and check out input map. So you can see that by default in your Godot project, there's a lot of these UI functions, and you could easily use UI right, up, down, and left to control movement as well. But in some circumstances, you might have the case where your UI keys for moving around an inventory or something are actually different from your player's movement. So it's up to you. You can modify this, rename it, or just create a completely separate function entirely. So if you want to create a new action, which each action can have different keys that actually trigger that action. You can see there's these D-pad keys, and then there's keyboard keys, which are different depending on what device you're using for input. So we can create an action by typing in the name of the action we want to create, like left, up at the top, hitting add, and then we can assign keys to this specific action. So then left is different from UI left. You may also notice that you can't double click on the default functions and rename them, nor can you delete them. So these actions are there by default, but you can remove keys from them if you desire. So if you just want to use UI left, we can just delete this extra left action, and you can just add any keys you want to be here. So you can either edit this key to something else, like let's say W on the keyboard, or actually this is left, so it should be A. Or you can delete the old keys, add a new one. However you want to set up, just make sure that the right keys and the right devices are set up for your directions. So the quick way to do it, I'm just going to edit this here, and I'm going to make right D. So I'm just going for standard WASD here. So up is going to be W, and then down is going to be S. And let's go ahead and close that. And now we can just check if the player is putting that input in. And then if it is, we'll use the input to determine which direction the character should move in and which animation it should be playing. So let's use another function here, underscore physics process delta, because we're going to be having the character move after we get the input. So movement should take place on the physics process, not the normal process, because anything that's going to be dealing with collisions should be checked at this physics process timing. So for this function, let's start by getting a variable, and we're going to call it var move input. And this will be equal to a different function we'll just go ahead and create called get, or let's say get directional input. I think that makes sense. Okay. And we'll go ahead, add a couple more lines. Let's create that function get directional. And this doesn't need any parameters. We don't really care about the delta, which is the time between frames for this function. We're just checking which keys are currently pressed down to give us the directional input for our move input. So add the colon at the end, and this will be a vector 2. So I'm going to call this var move input vector, and this is going to be equal to a vector 2, and we're going to create that. So you need parentheses. You can see it takes a x and a y value. So I'm going to add a couple lines here. So x is going to go here, y is going to go here, and then at the end, we're going to return that move input vector. So how do we calculate the final x input? So we need to see how far the character is pressing to the right and how far the character is pressing to the left. Left is negative for our 2D game, and right is positive. So if our final move input vector is +1, then the character is going to end up moving to the right. If it's -1, it's going to move to the left. So we want to do input dot get action strength, I believe, and that's going to be UI right. So this will either be somewhere between 0 and 1. On a keyboard, it's always going to be 0 or 1 because it's either pressed or it's not pressed. And then we're going to subtract the UI right. So input.get action strength UI left. Okay, and the reason we subtract is because left is a negative value on the screen. So the strength value is still going to be between 0 and 1, but we want to make how it affects this X negative because UI left should make us move left on the screen. So that's how we get our X value. And then down here, we need to do the same thing with UI up and UI down. It's a little bit tricky because, but we actually start with down because down is positive Y on our screen. And then we subtract input.get action strength UI underscore up. Okay, so now we get our movement input vector, we return that, and we can use that here for whatever we want. So we should check if we're actually getting the right values. So I'm going to print, let's say, a move input. So this will print the vector to our output, this console log down here, when we're in game. So let's go ahead and hit play and go in game and see what we've got right now. So you can see 0, 0 is our default, but if I do WASD, so W, -1 on the keyboard, S is 1 for the Y value, so positive down. A, left is -1, and then right is +1. So now we can take this directional input and then multiply it by move speed in order to determine how fast our character should move around on the screen. So let's create a variable up here that we can actually just click on our player and be able to set it over here rather than having to go into the script every time. And the way we do that is you do export and then you type in the type of variable. So in this case, I'll say that the move speed is a float, meaning it can have a decimal point if you want it to. Variable move speed, and we'll default that to something like 50 pixels per second. I believe that is what it would come out to. Okay, so now in our physics process, after getting the movement input, we need to actually move our character. So we can use a function called move and slide for that. So I'm going to type down here, move and slide. And this is going to basically take a vector, which in that vector contains our direction and our magnitude. So our direction is the move input, and then we multiply that by our move speed. Now, normally when you keep cycling through a process function, you would want to account for delta, which is the time between frames, so that if you have very fast frames, that your character doesn't move that much. And then when you have very slow or laggy frames, maybe there was lag in your game and it wasn't playing back as fast as it should, that if there's a huge gap in time between frames, then your character should move a lot between frames. But if you were using move and collide, you would need to multiply by delta. I'm not sure why in Godot move and collide needs delta and then move and slide doesn't, but that's just how it works as it is right now. So move and slide, move input times move speed, and this should give us the ability to move our character around on the screen. So I'm going to hit play, and then I'm going to use WASD to move. So D, we move to the right, A, we move to the left, down, we move down, and it's important to check that so that when we got this action strength, UI down minus UI up, that we're actually going the right direction. And then I press W, and this is giving us a -1 for the direction, which is actually up on the screen. And you'll notice we can also do a combination. So if we press down and right at the same time, we move diagonally down and to the right. And rather than having state machine.travel walk right up here, what we can do is set up a enum variable where we basically have states referenced in code. And then when we switch states, we can also switch the animation using the travel function. So let's go up here, and I'm going to create, actually up at the very top, I'm going to do enum state. I'm going to make that all caps. And then in here, we're going to have two states, idle, all caps, and move, or rather, let's call it walk. So if we switch between these states, we can control the travel function as well when we enter those states. But right now, this enum just defines the names of those states. It doesn't actually switch between them yet. So we need another variable for that. So go down here and create a variable. I'm going to call it current state, and this is going to default to idle. But for this function, when we set it, we want things to happen when our state changes. So I'm going to add set get at the end here so we can create a setter method. And this is going to be set current state, all lowercase. And we can go ahead and hit Control S there. So let's see. So when we're setting our current state, this should be state.idle. Okay, that's how you reference a enum. Okay, and you can see we still have an error. The setter function isn't defined. So if we hit enter a couple times, we can actually write that right here. So function set current state. And because this is a setter function, there's going to be a value passed in. So when we do current state equals a value, it's going to enter here and it's going to bring in that new value as a parameter. So we can call this new state. It really doesn't matter. You can call it anything you want. It's just, this is going to be the name of the value that just got passed in. So first I want to check if the current state is already the new state. And if so, we're just going to skip over all of this because if the state hasn't actually changed, we don't really care to run any extra functions. So if new state is equal to current state, then I guess we just return. Otherwise, let's take the current state and use a match function. So match on the current state is going to take whatever. Otherwise, let's take that new state and run a match function on it. So match new state. And what this means is that we're going to take whatever value is in here and match this to a few different possibilities. So those possibilities are going to be these states up here in enum state. So if the new value being passed in is state.idle, we want to do specific things. And if the new state is state.walk, we want to do slightly different things. And now down here, we need to write the thing we're matching for. So state.idle is our first state. And then a couple enters, and then state.walk is our other possibility. So when we enter state.idle, we want to travel the state machine until we get to idle right. And later it will be idle any direction depending on what directional input we have here, but we can start with idle.right. So let's see, state machine dot travel, and we want to travel to idle right. And when we have state walk, we want to travel to walk right. So travel walk right. Okay. And now we just need to set the current state when it's appropriate. So we can either use the velocity, which is going to be returned from this move and slide function, basically the amount that it's moving in a certain direction, and that's of course the kinematic body, the player, or we can use the move input for that. So if the character moves up against a wall and there's a collision, then the velocity might be 0 in that direction, but the move input is still +1 or something. So it will look a little different depending on if you use the move input to determine if it's an idle or walk, or if you use the actual velocity. For now, I guess we'll use the move input. So now down here we can say if move input does not equal vector2.0, in other words, there's some kind of movement input, then we'll make the current state. Oh, and when you're calling that from in here inside of the own script, if you actually want the setter function to get ran, you want to do self.currentState is equal to state.walk. Self.currentState equals state.idle. Now, of course, this is like a really, really simple way of controlling the state. And when you add extra functions to the character, like maybe attacking or that kind of thing, then this logic won't really make sense, because you could technically have move input but not want to be in the walk state. So you'll have to set up extra conditions in order to filter to which state it should really be in. But for right now, with only 2 states, this will technically work. So it's either going to be state.walk or state.idle. So if the vector isn't 0, then we do state.walk. Otherwise, the vector is 0, there's no movement input, we do state.idle. Now before we run this, let's go ahead and get rid of this ready function. We don't want to start the game at walk right anymore, we want to start with idle right. So let's hit play and see where we're at. So the character's not moving. I press right on the keyboard and we enter the walk right animation, but it doesn't actually exit out of that automatically either. So let's go back. We can see if the move input is not 0, then we should enter state idle. We can check the animation tree and make sure that idle right is actually there. And we can see that there's still a connection between walk right and idle right, so it should be able to get there. Let's add a debugging point by clicking over here in the script and then hit plus and see if we can actually get that to trigger. So I'm going to press right and our character moves, but we don't actually return to idle right when we let go of the keyboard. The problem is that when we pass in this new state, we didn't actually change the variable. So one thing to remember when you're doing the setter function is actually to set the variable. So current state equals the new state. So that's important here. Otherwise, the current state will never be properly updated if we're using that setter function. So now we can go ahead and hit play here. Actually, I'll just turn off the breakpoint. Let's go ahead and hit play. And we should be able to press a key and enter the walk right. And we let go and we go back to idle. So that's how it should be. We should be able to actually change that current state function. So now this is basically working, except we have one final problem, which is that we have no up animation. We have no down and left animation. So let's go ahead and clear those up. So let's click on our animation tree, go to 2D view, and we need more animations. And we also need blend trees. Let's start with creating the animations. So I'm going to click on animation player and let's duplicate this walk right animation. So click on animation, duplicate. Now we have walk right copy. Let's rename this to be, I think walk up is the next set of frames. So walk up, I'm going to select the first frame coordinate, or rather, actually easier. Let's click on sprite and let's increase this value to 6. I think that's where the frame starts. And once again, you can always just go look at your sprite sheet and just count the number of frames. So you can see we have 6 over here. So this is 0, 1, 2, 3, 4, 5. And then we start from 6 and we go up to 11, I think. So if we do frame coordinates 6 here at 0 seconds, I'm going to keyframe that in. So type 6 and then hit keyframe, and then that will replace the frame coordinates for this animation. And then we can just keep clicking 7, 8, 9, 10, 11, and we're done. So let's play this animation to test. And there's our walk up animation. Now we just need to repeat that for walk right and then walk down. So I'm going to click animation, duplicate, and then click up at animation, rename, and let's call this walk right. Oh, walk left, actually. Okay, so let's find the next set. So theoretically, this should be 12. Okay, we have that. So queue up the timeline position at 0 and then to frame 0, hit play, and it's all working good. When you duplicate from a existing animation that's similar, it's going to save you some time because you don't need to check is looping. You already have the right animation time set and it's already in discrete mode. Okay, so let's just finish this part up with duplicate and then we rename it. So this is going to be walk down. So let's see, 12 plus 5 would be 17. So this should be 18 in this sprite sheet. Okay, there's the first frame. So I'm going to keyframe, 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 keyframe. And we test our animation. There it's working perfectly. So now I can switch between walk left, walk right, walk up, walk down. Now for the idle, that's going to be much easier because those are just one frame. So let's go to idle right, and I'm going to duplicate this. So let's rename this to be idle up. Okay, so our frame coordinates are going to be 0 and then 1. Once again, consult your own sprite sheet and then keyframe that. Okay, and that's it. So let's duplicate this and then rename it. Idle right. I made the same mistake twice. Idle left. Okay, let's go to the start of this animation. Put it at frame coordinates 2 and then keyframe that to replace the frame coordinates. And then let's duplicate it one more time. I'm going to rename this. So the last one is idle down. So another way we can change it rather than using keyframe is just to select the existing keyframe, clicking on it, and then change the value. So this is going to be value x of 3. And you can see it updated down here. But if we hit play, well, now it'll be playing the actually correct animation there. You may also want to toggle on animation looping I think it actually makes sense. I'm going to animation loop all of these idles, even though there's no real animation going on there. If we ever added extra frames to it, it should be looping while the character's just sitting there. Okay, so all of our animations are looping now. So let's go to the animation tree, and instead of having these single animations, we need a blend space 2D. So in the blend space 2D, we can set the X look direction and the Y look direction to determine should it be looking left, up, down, or to the right. So let's right click and add a blend space 2D. And then I'm going to click on the name here and rename this idle. And let's right click and add one for walk as well. So let's go into idle here. And then you can see that there's obviously a 2D graph here. So you have a left over here, up, down there, down below here, and then right to the right over here. So we just need to add our 4 animations at these 4 points. And then we need to control the Y and X values here for this blend space in order to determine which direction the character should be facing when it's playing an idle animation or when it's playing walk right. So one tip I've seen is that if you want left and right animations to be prioritized, you can change the Y max here to 1.1 and then the Y negative to 1.1 as well. So now if we position our animations up here at the top, it's going to be harder in a sense for our animation to choose to blend to the up value than it is left or right. So if our values are 1 to the left and 1 up, it's going to select the left because in a sense, our Y value is less powerful. I guess that's one way to look at it. So I'm going to click up here with this tool selected, create points, and we're going to create the point. And then I think we want walk up here. It could be wrong. It could be walk down. We'll have to test that. Okay, and then we click up here and we're going to add the animation. I think we want idle up here. It could be wrong. It could be idle down. We'll have to test it. But let's add those points in. And then down here will be idle down. To the right over here is going to be idle right. And then to the left over here is going to be idle left. So as our XY values change, it's going to blend between these animations. So I can actually just kind of drag this around. Well, it's not going to show anything yet because we're playing idle right. We're not playing this idle. So let's click on idle and then autoplay it. Okay, and then I'm going to click there and make sure it's playing here. So now if we go into the blend space 2D, we can move this around in order to show which directional input we should be having here. So you can see how we can switch between our 4 idle directions. Okay, and now we basically need to set the same thing up for the walk. So I'm going to go in here, make 1.1 for the Y and negative 1.1 for the other direction. And then let's add in our points. So we want walk left over here, walk up over here, walk down here, and then over here is going to be walk right. And we're going to blend between those. So now, rather than connecting a travel connector between one single animation, we're connecting travel connectors between blend trees. So let's click on connect to nodes, connect idle the blend tree to walk and walk to idle. So now we're going to travel between idle and walk, but the exact animation which gets selected is going to be from the parameters we set for these blend trees. So if you click on animation tree, you'll see that there are parameters now. If we expand idle and walk, we have blend position. So we need to set those blend positions in order to help the blend tree pick out which animation it should play. So these should always default to 0, 0. Of course, when the game loads, it shouldn't be putting the character in a certain direction unless you want to force it to do that. And now we can go into the script and we can set those parameters whenever we get movement input. So we can check the path to these parameters. So you can see parameters idle blend position and parameters walk blend position. So this is like this parameters playback. It's just another type of parameter. And we can set these values, and we need to set an X and a Y value, or really we'd need to set a vector. So when we get our movement input, that's when we're going to set the blend positions. So let's create a function here. I'm going to call it update animation parameters, and I'll pass in the move input. Let's go down here, function update animation parameters, and we take the move input. I'm just going to put a colon in here and define that this should be a vector 2. So it's not required, but this is going to be kind of like a hint so that we know what to expect when we run this function. And then we're going to take this and we're going to set these parameters. So we already have reference to the animation tree at the top of our script here. So in this function, animation tree underscore tree dot set the parameter, and we want parameters slash idle slash blend position. Okay, and you can see that same name is right here, parameters idle blend position. I think we can actually just put the move input. Let's just try that. And then let's set the other one as well. So animation tree dot set parameters slash walk slash blend position. And that's going to be move input. Okay, so now our move input is going to control which direction the character is looking for both walk and idle animations. So as long as this runs every time we get the move input, it should be good to go. So let's go ahead and, well, first let's delete these extra animations here. These are no longer needed because idle right and walk right, those are already located inside of these blend trees. So let's go ahead and hit play now and see if this is working. So I'm going to hit right. Okay, our character is facing to the right. That's good. Up, down. Okay, it seems quite broken here. Let's check the debugger. What's going on here? Errors. So we changed the name of the animation, so we need to change what we're traveling to. So in our script, we have travel idle right. Let's just change that to idle, and then we change this to walk. So we only need to tell it to go to these blend space 2Ds, and the blend space 2Ds will handle the rest. But you do have to put the right names here to correspond with those. Okay, now we can go ahead and hit play, and we can see if it's going to work. So we press right. Okay, we're walking to the right. Now it's facing to the left. Okay, we press left. It's facing left, and down is actually not helping there. And up is not as well. So I think I made a minor mistake with the blend space 2Ds. I think that although you make the graph 1.1, you actually only make this point go to 1 and this go to -1. And then we need to do the same thing with walk and walk down as well. Okay, let's try that one more time. Let's hit play. Okay, so now walk down faces up, walk up faces down. So it's a little better, but as I had suspected, we have the directions reversed. So click on this one and change this to idle down. And this one should be idle up. Now we go to root, edit walk. So we want walk down is the top value, and then down here, walk up is down there. So if we hit play, when we press down, our character is going to actually walk down. When you press up, our character walks up. When we press right, our character walks to the right. Now let's press down and right at the same time. And you can see that it keeps walking to the right, left and down. Okay, not quite there. Okay, maybe what we actually needed to change wasn't this being a 1.0 value, but to change the blend mode to discrete. So I'm going to change it to discrete, and let's move it back to 1.1, 1.2. Okay, so 1.1's there. This is 1.1. Let's do the same thing with idle. So blend mode discrete, just like the animations. And let's move those down. Okay, now if we hit play, let's walk to the right and down. Okay, that's good because it should prioritize right over down. If we press up, we go up. If we press down, we go down. But if we press left and down, we go to the down left. And if we press up and left, we go to the up left. Okay, so that's what we wanted it to be. So 1.1, but change the blend mode to discrete. So the last little thing is that if the character stops moving, if we stop putting input in, that it still updates the animation parameter. But when our character stops and switches to an idle, it should be idling in the same position. It should be idling in the same direction it was moving in. So rather than run update animation parameters up here, we should just take it down here and set it here. So update animation parameters will only happen when the movement input is not equal to 0. Okay, so now if we hit play and we press right, we move in a direction and we let go, it's still going to be facing the right. Likewise, if we press left, it's still facing the left. And if we press down, it's still facing down. If we press up, still facing up, and so on and so forth. So now our character moves in all 4 directions correctly using those blend spaces.